Hello students, yesterday I got request to solve one of a challenging problem from a NASA book which we don't use. So I'm going to show you how to solve this challenging problem, but I will just show the part A, okay? Now the problem is 91. So distance between points in a plane do not change when a coordinate system is rotated. So here we're talking this coordinate system, which is S coordinate system and S dash coordinate system, okay? So basically, the magnitude of the vector is invariant under rotation of the S coordinate system. Suppose the coordinate system S is rotated about its original by angle phi to become a new coordinate system which is S dash, as shown in the figure below. Now, a point in a plane has coordinates x and y, then in a S coordinate system, and we also have x dash y dash in a S coordinate system. So in a part A, basically you have to show that during transformation of rotation, the coordinates in S dash are expressed in terms of coordinates in S by following relation. So which is, we have to show that x dash is equal to x cosine phi plus y sine phi, and y dash is equal to minus x sine phi plus y cosine phi. Okay, this is what we have to show. Now, first of all, we have to prove basically this one. But before proving it, let's first define what are the x and y components in a S coordinate system. Okay, so let's draw a vector. Okay, this vector, let's call it P vector. Okay, now, and then we can find what is the x component, this one, and what is the y component. Okay, now what is the angle here? What is the angle here? So the angle, basically, we can define that. Let's say that this is our theta. Okay, this is our theta. Now we can say that our x coordinate is equal to P vector, which is multiplied to the cos theta. Okay, then we can say that y is equal P multiplied to the sine theta. Correct? Right. Now, let's write it down like this one. Then let's find when it's rotated, S coordinate system, when it's rotated by phi angle, it becomes new coordinate system, which is S dash. Okay? When it's rotated, then how can we find the new x dash and y dash components? Okay, so that means we can say that our x dash is equal to P multiplied, okay, so it becomes, let me choose another color. It becomes this angle, right? This angle, let's call it alpha. Okay, so x dash is equal to P multiplied cosine alpha, then y dash is equal P multiplied to the sine alpha. Now we know that our alpha is equal to theta minus phi, correct? So that means we can say that P cos theta theta minus phi, right? Then P sine, here again theta minus phi. Okay, now we got components x and y, and also we got the components for x dash and y dash. As you can see here, p is not changing, so p is the same, p vector is the same. Now, before moving on, I think we have to know that when cos theta minus phi is equal to what? Cos theta minus phi will give you a cos theta cos phi plus sine theta times sine phi. Okay, then what about sine theta minus phi? The reason that we're interested, we want to find this cos theta minus phi is equal to what, and sine theta minus phi is equal to what. So then we can say that sine theta minus phi will give you sine theta cos phi minus cos theta sine phi. Okay, let me highlight it. Okay, then what we have to do now, we have to find it, saying that our x dash was equal to p cos theta minus phi, right? Which means we already found that cos theta minus phi is equal to cos theta cos phi plus sine theta sine phi. So that means we can say that p multiplied to cos theta cos phi plus p multiplied sine theta sine phi. Correct? Now, what we have to do now? Okay, so we know that from here we can say that okay, so we know that, okay, x is equal to p times cosine theta, right? Okay, very simple. So that means we can say that this one is equal to x, right? Then that one is equal to y, correct? So at the end we can just say that our x dash is equal x cosine phi plus y sine phi. Okay, this is how we solve for the x dash. What about y dash? So for the y dash, we can say that it was p sine theta minus phi, correct? So that means we can use this one, which means p sine theta cos phi minus p cos theta sine phi. Again, we can say that p sine theta is equal to y, then p cosine theta is equal to x. So finally we can say that it's equal to minus x sine phi plus y cos phi. So we have proven that we have proven this equation, that x dash is equal to x cos phi plus y sine phi, and y dash is equal minus x sine phi plus y cos phi. So the part B and C, I think I will just leave it for you. This is just a start, that the rest of the thing will be just follow, the previous one.